Black holes are some of the most mysterious and powerful objects in our universe. They are so dense that not even light can escape their pull. For a long time, black holes were thought to be just theoretical ideas, strange solutions in math with no real existence. But today, thanks to modern science and technology, we know black holes are very real. They influence the galaxies and stars around them in ways we are just beginning to understand. Michio Kaku, a famous physicist, and others propose that black holes might not be the dead ends we once believed. Instead, they could be something much more exciting: gateways. These gateways might be wormholes or bridges connecting one place in the universe to another, or even to parallel universes. A wormhole could let something pass through a black hole and come out somewhere else, possibly far away or in a completely different dimension. At the other end of this bridge could be a white hole. Unlike a black hole, which only pulls things in, a white hole only pushes things out and nothing can enter it. This idea is strange but fascinating. This idea comes from Einstein's field equations combined with quantum mechanics. Both theories describe how the universe works, but they don't always agree. When combined, these equations sometimes hint at the existence of bridges called Einstein-Rosen bridges. These are wormholes, theoretical tunnels connecting different points in spacetime. Under normal physics, these bridges are unstable and collapse too quickly for anything to pass through. But some scientists think that if exotic matter with negative energy exists, it could keep these wormholes stable. Exotic matter is not like anything we know on Earth. It would have strange properties that allow it to hold open a wormhole long enough for travel. Though these ideas might sound like science fiction, they are based on real science and serious math. They push the boundaries of what we understand about the universe. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole's shadow. This black hole lies in the galaxy M87, far from Earth. The image showed the black hole's accretion disk, a swirling ring of hot matter falling into it. It also gave us clues about how space and time bend near a black hole. This achievement was followed by a clearer image in 2022 of Sagittarius A*, the supermassive black hole at the center of our own Milky Way galaxy. Seeing these images was a huge leap for science. It proved that Einstein's predictions about space-time bending near black holes are correct. But the discoveries did not stop there. New research suggests that black holes might store vast amounts of information. This idea challenges the long-held belief that anything that falls into a black hole is lost forever. This leads to a famous puzzle called the information paradox. If information really disappears inside a black hole, it breaks the rules of quantum mechanics. Physicist Stephen Hawking proposed that black holes slowly lose energy by emitting what's now called Hawking radiation. This radiation is a faint glow of particles escaping from the edge of a black hole. But if black holes evaporate, what happens to the information they swallowed? Does the information escape somehow with the radiation? Is it stored on the black hole's surface, called the event horizon? Or is there a deeper, unknown part of physics we haven't found yet? These questions are very important. They are not just about black holes but about understanding the fundamental nature of reality. Solving the information paradox might help us create a theory that unites general relativity, Einstein's theory of gravity, with quantum mechanics, the physics of the very small. These two great theories have worked incredibly well but have never been fully combined into one unified framework. Some scientists even speculate that black holes could be the birthplaces of new universes. When matter collapses into the center, called a singularity, it might rebound instead of vanishing. This rebound could create a new universe, separated from ours by a boundary that nothing can cross. If this idea is true, every black hole might contain an entire universe inside it. Our own universe could be the inside of a black hole in a bigger cosmos. This would change how we see everything, placing us in a vast multiverse of countless nested worlds. Even though these ideas are not yet proven, every new discovery brings us closer to answers. In the coming years, new tools like the Large Hadron Collider, the James Webb Space Telescope, and the Laser Interferometer Space Antenna (LISA) will let us study gravity, time, and space more deeply. Scientists from many fields are working together, using mathematical models and quantum simulations, racing to unlock these cosmic secrets. So, what exactly lies inside a black hole? Is it a singularity, a point of infinite density? Is it a wormhole to a far galaxy? Or maybe a door to another dimension, or even a womb for a new universe silently growing beyond our reach? We don't know yet. But one thing is sure. Black holes are much more than just cosmic vacuum cleaners. They are clues to the deepest mysteries of reality. Each new theory, every new observation, peels back the veil just a little more. As we look into the darkness of a black hole, the darkness stares back, not as an empty void, but as a mirror reflecting the greatest questions we can ask. If this exploration has inspired you, make sure to subscribe to Discovery 2.0, where we unravel the greatest mysteries of science and space one revelation at a time. Like the video, hit the bell for future updates, and share your thoughts. Do you think wormholes could really exist inside black holes? Could they be the key to traveling across space or even time? Thank you for joining us on this cosmic journey. Until next time, stay curious. Black holes are mysterious, massive, and all-consuming objects in the known universe. Some weigh millions or even billions of times more than our Sun. Their gravity is so strong it can warp space-time, shred stars, and swallow everything, even light itself. For centuries, black holes were just strange mathematical consequences of physics equations, ideas without physical proof. But monumental advances in technology have allowed us to observe black holes directly and explore their astonishing properties. Theoretical physicist Michio Kaku has proposed remarkable ideas about what might lie inside black holes, ideas that stretch the imagination and scientific understanding. To understand this, we first need to look at the foundation of black hole knowledge. The idea of an object so dense that light cannot escape dates back to the 18th century. However, it was not until Albert Einstein's general theory of relativity in 1916 that the idea gained scientific support. Einstein showed that mass and energy bend the fabric of space and time, predicting gravitational monsters so powerful they trap even light particles, called photons. Even Einstein hesitated to believe black holes were real. For decades, they were viewed as mathematical oddities, solutions to equations, but not physically possible. This changed dramatically in the 1960s when scientists detected strong X-ray emissions from a strange object in the constellation Cygnus. This object, called Cygnus X1, was confirmed as the first known black hole. This discovery changed astrophysics forever. Black holes became real and dangerous objects existing in the universe. Since then, astronomers have found many stellar mass black holes and several supermassive black holes at galaxy centers. Our Milky Way contains a supermassive black hole named Sagittarius A with a mass over 4 million times that of our Sun. Its gravity shapes the orbits of nearby stars and influences the galaxy's behavior in ways we are only starting to understand. Why study black holes if they seem so destructive? Because they test the laws of physics under the most extreme conditions. Near a black hole, gravity, electromagnetism, and nuclear forces act in ways that challenge our knowledge. Time slows down, space warps, and particles face forces impossible to recreate anywhere else. Black holes are nature's ultimate laboratories. The event horizon is the invisible boundary around a black hole. Once something crosses it, escape is impossible. It's a cosmic one-way door. From outside, we cannot see what happens inside, but we know black holes by their effects on nearby matter and light. Sometimes, when black holes collide, they send ripples through space-time called gravitational waves. Instruments like LIGO and Virgo have detected these waves. Falling into a black hole is deadly and strange. To an outside observer, a falling object seems to slow and freeze near the event horizon due to warp time. But for the object itself, time moves normally until it is pulled into the singularity, a point of infinite density where space and time break down. At the singularity, all known physics laws fail. Gravity is infinitely strong, and our equations produce infinities, Signs that our models are incomplete. Modern physics cannot explain what happens beyond this boundary. Scientists like Michio Kaku think what lies beyond the singularity may hold the keys to the universe's deepest mysteries. His theory involves wormholes, tunnels through space-time that connect faraway points or even different universes. Subscribe to our channel and thanks for watching.